Hello. Hello.
Yes, sir, you are audible.
Yeah. So, how is life? Did you guys go over this stuff that we were doing? This dynamic programming. I think Shayantan has shared a list of questions yesterday night on dynamic programming that I think he will be covering in the that will be covered in this week's tutorial also. So, any questions of whatever has been done so far? Okay, so if not, I think we can start with whatever we were doing. So let me just share my screen. So we were basically trying to solve the longest common subsequence problem in the last class, and I asked you guys to go back and think about this. And I'm hoping that you guys have done that. So let's see. So just to recap, what is the longest common subsequence? So it is you have been given two strings, and it is the longest string of ordered letters that are there in both of them. So they don't have to be consecutive. So for example, in this example of mathematics and education, you can have maybe TI is one option. So T and I. So this is T and I. But maybe you can have a little bit more, maybe ATI. That is also an option AT, and then it's I. This is also ATI. And maybe there's something more. In fact, let's see. I think there is something. Oh, EATI is the longest common subsequence between these two strings. So similarly, in this, the longest common subsequence between the villages and cities is, so it can be I and E. I and E is IE and this IE, or they can be IES, and possibly that is the longest common subsequence. So, so this is some problem that we were trying to solve. And basically, formally speaking, we have these two strings, A1 to AN and B1 to BM. And we want to find the longest common subsequence between A1 to AN and B1 to BM. The question is that how do we go about it? So did you guys think about it?
Sir, the problem was to find the subsequence or length of the subsequence.
Okay, so let's first start with the length of the subsequence. The length of the longest common subsequence. Actually, you can even find the subsequence also in the same way. But let's start with the length of the length of the largest subsequence. So let me see. So have you all guys tried?
Yes, sir.
Yes, sir.
So if you say yes, or if you don't answer, that means I'm assuming that you have tried, right? So let me start with someone. Shubhimoy, are you there?
Yes, sir.
Yes. So how will you go about it?
Sir,
Yes.
sir, actually, we have to find the intersection string of first string and second string,
Right.
and first we compare the
First you compare the So Shumi, are you trying it right now, or did you try it at home?
sir. Home, sir. Actually,
You've tried it at home, and you are still cannot say anything about how you can proceed or something. Okay. Thomas Kanti Gorai?
Yes, sir.
Yes. Can you tell me?
Sir, I have done this uh, using the previous class, that edit distance class.
That's fine. You can use the edit distance techniques and all. I mean, but it is not an edit distance problem.
Yeah, I know that, but I use the concept of that problem.
Yes. So how will you go about it?
I take if the last two characters are same,
Yes.
an and bm,
Yes.
then the longest common subsequence length will be the longest common subsequence of a1 to an minus 1 and b1 to bm minus 1,
Right.
and I will add 1 to them because an and bm are
Correct.
same.
Very
So
good.
I can take that and add that to the longest common subsequence of the smaller subsequence part.
Very good. Yes.
And if an and bm are not equal, then there are two possibilities. An can be included in the longest common subsequence.
Yes.
In that case, I will find the longest common subsequence of a1 to an and b1 to bm minus 1.
Very good. And otherwise, you will take this.
Other case is bm is included in the longest common subsequence, an is not. Then in that case, I have to take a1 to n minus 1 and b1 to bm.
Correct.
And I have to take the maximum of these two.
Exactly. That's 3. You take the maximum of this 3.
Hello?
Yeah. So you have to take the maximum of this 3, right?
Yeah.
Okay. I mean, okay. The third one will come up if n is not equal to m. Right. So very good. So that is exactly what the recurrence will be doing, right? So, okay. So of course, we have discussed this one, that we have a brute force method where we can go over all possible subsequences, but that's too costly. But if we define a more recursive way of doing it, in which we can break it down to some smaller problems. Okay. For example, we can define this LCS of ij. This is the longest common subsequence between A1 to AI and B1 to BJ. Right. Of course, our goal is to find LCS of n comma m. So question is that how can we find out LCS of n comma m? By using maybe the LCS of the smaller ones. So of course, there are this kind of the base cases that we can think of, that if one of them is 0, means LCS of any value comma 0. I mean, there's no common sequence because 0 basically means the empty string. And similarly, LCS of 0 comma anything is 0. Question is that what is the LCS of this whole thing? And the main idea is exactly as you explained. So we want to output, say here in this case, villages and cities is the LCS of villages comma cities. Say villages have 8 of them, cities have 6. Now the first things to note is that if the last two terms are same, which in this case is, so whatever happens, if you have talking about longest common subsequence, maybe this S gets mapped to some other S, doesn't matter. There will be another way of presenting a longest common subsequence where these two S's will be used. Okay, so I'm not saying that all longest common subsequence between these two strings has to use the last bit, but I'm saying that there exists a longest common subsequence that uses the last bit if this last bit is same, which is this case is. So in that case, since S's are same, so all we can say is that okay, the longest common subsequence, the length of the longest common subsequence between 8 and 6 must be the length of the longest common subsequence between the first 7 and this first 5, so 7 and 5, and one more added. Okay. Now, if you go and talk about what is the longest common subsequence of A, 7, and 5, again, since the last two bits are same, which is E, we can also do the same thing here. So we can kind of add them. Okay, so we get to LCS of 6,4. So now we come to this stage where I, last bit is I, and this is G. Now, what can happen? Now, of course, you cannot have both of them as a part of the longest common subsequence. Is it possible? Can there be a longest common subsequence containing both this I and this G? Bishwajit Mondal, is it possible? Hello, Bishwajit.
Sir, can you repeat the question once? I didn't get.
Is it possible that LCS of 6,4, the longest common subsequence between village, VLIJ, VILLAG, and CITI, both I and G are part of the longest common subsequence?
No, sir, because the last two.
No, hold on.
character we have
Thomas,
fixed.
Thomas,
So-
hold on. Bishwajit, can you just answer? Bishwajit? Bishwajit, can you hear me? Can rest of you hear me?
Yes, sir.
Okay. So, okay. Let me ask somebody else. Dhananjay, are you there? Dhananjay, are you there? Dhananjay is also not there. Dhananjay, are you there? No. Venkatesh?
Yes, sir.
So can you tell me, is it possible that the longest common subsequence between these two strings, VILLG and CITI, can
Yes.
they contain both I and G?
Sir, if G to be in the longest common subsequences, then CITI, the subsequences which is remained in this string 2 will have G, should have G.
Yes.
And to I to be present in the longest common subsequences, then this remaining subsequence of string 1 should have. But this both can be in longest common subsequence. Sir.
Both can be at the same time in the longest common subsequence, is it?
Both can be possible.
Okay, so if I had something like CIGI instead of T, if it was G,
Then G will be there.
then G can be there and I can also be there.
Yeah. Yes, sir.
So you are saying that there can be a longest common subsequence between
But
B.
then the order will change, right, sir?
Sorry, I don't get you.
Order.
Yes, what will be the order? So if I have something
CI
like Z, and if I have something like,
CIGI.
is it possible that a longest common subsequence contains both this G and this I?
See here, I G is there, order, but here GI is okay. Yeah, it might happen. It might happen, sir.
It might happen.
Yes.
Okay, in that case, how can it happen? Think a bit. Is it really possible that both? I understand that it might be there can be one longest common subsequence which contains I. There can be some other longest common subsequence that contains G. But can the same longest common subsequence contains both G and I?
Okay.
So it can contain G and I, but not this G. There may be some.
Yes, I mean this G.
G4, but
I
not
really
this
mean
G.
this G. Yeah, is it possible that it can contain this G and this I?
No, sir.
Sir, is there any distinction between this G and any other G?
Yes, of course. What do you mean? This distinction means what? They said there are lots of G's, but the ordering that matters. The longest common subsequence is a subsequence where we are picking up a set of subsequences, right? For example, say
Yes, sir. Means we will take all the subsequence, and the longest one will be union of all those. So it
what?
will
Who is it who is saying?
Sir, I'm Devrup. I'm actually saying that, sir, there can be lot of subsequences, and the longest one will be union of all those.
Longest one is the union of all the subsequences. Okay, so what happens if I have this thing A, B, C, D and D, C, B, A? What is the longest common subsequence between these two strings?
ABCD only.
A, B, C, D is the longest common subsequence between these two strings?
Yes, sir. But does the order matter here, sir? I was just thinking is it as two sets.
Yeah, Ayushi, what you are saying something?
There is no subsequence according to the order.
There is no non-trivial subsequence. There is a subsequence. A is a subsequence.
Single is there. Single.
Even C is there, or B is there, but there is no subsequence
More than
because.
actually.
Sorry,
There is no subsequence more than order 1.
more than order 1 because the example that we talked about, exactly this definition of the subsequence, we need this ordering. Very crucial. That is the reason, say, for example, here when we did it, it is EITE and not, say, the C cannot be a part of the subsequence. E8, because in that case it is ECATI and this is ETIC. Although C is a part of them, it is not, because they doesn't fit in the correct order. A subsequence means the order matters.
Sir, you
Yeah,
are asking about G and I, this question, right?
Yes.
Longest common subsequence.
yes,
So if there is a longest common subsequence for this two, it is 6 and 4, right?
yes,
I mean 6 letters and 4 letters. If there is
Correct.
a longest common subsequence for this, then it should have a length. So then that might end with G or I.
that might end with G or
Not
I.
both G and not both this G and I.
Exactly. The longest common subsequence is a particular subsequence. It's not a union of subsequences. It's a subsequence. It's a string, right? That string can finish with something, but not with two things, right? It can finish with I, it can finish with G, it can finish with anything else, but not in both. If subsequence contains I, this I, if the subsequence of CI contains this I, since this I is the last one in this word, so this subsequence must end with GI. Similarly, if a string is a subsequence of VILLAG, and since G is the last one here, the subsequence must end with G. So it is not possible that the longest common subsequence, which is a subsequence of both VILLAG and VCIGI, contains both this G and this I. Is this clear?
Yes, sir.
Okay, Devrup, are you there?
Yes, sir. I was thinking.
I mean, you are not thinking, and you are neither you are working on anything. And clearly, I can say that because you have
Actually,
not
sir, I
thought
was
about this
trying
problem.
to find the
You have not thought about this problem at all before today's class, right? You have not gone and opened up whatever has been done in the last class also.
Actually, sir, I have gone through and I did the solution with Tamosh only. We are doing it together. I was thinking of, at first I was thinking of consecutive, I was thinking of it will be consecutive, but after he said that it wasn't consecutive, I thought of that we have to find the intersection of them. That's why I was telling that thing that means I was not thinking about the order. That's why I did the mistake there actually.
Deeprup, I mean, I can only say that, I mean, if you are not putting in the effort and you are trying to fool, you are not fooling me, you're fooling yourself. Okay. The same is true for Shubinoy. You are clearly not thinking about this problem. You guys are all grown-ups, adults. I don't think I need to tell you guys that you have to put in the effort. And if you are trying to fool anybody, it is you guys. The people who are unable to answer me, I'm taking this DP thing very slowly. As you can see, I have done 3 things in 2 classes. Whereas I have one slide, usually I do them in much more faster way. And yet you guys are not putting in the effort. This is after they had a disaster of a midsem. I mean, I don't know how, what can I tell you guys? This is just not, it's just not fun. I mean, if you guys decide not to learn, who am I to teach you how? If you decide not to cooperate, then fine, go ahead. I will not think twice to fail someone in this course. I mean, remember this thing that you guys did not do well in your midsem, not because of the exam was hard or not because of offline, online, whatever crap. It's just because you guys did not study. You refused to study anything. I mean, if the midsem score is not a wake up call for you guys, then what, I don't know what is it. Yeah. Anyways, I hope you have understood it. If you have not understood it, then please let me know. I think, I mean, we have to somehow progress. If you guys don't, if you refuse to try, and if you even refuse to tell me when you are not understanding something, then what can be done? I mean, nothing much I can do. So any doubts about this fact that if you have 2 strings ending in 2 different letters, then the longest common subsequence cannot contain both of them? This is no algorithm. This is simple, basic, normal, common sense. Is this clear? That the last 2 things cannot be there?
Yes, sir.
Yes, sir. Okay. So if that is the case, so now we are back to 2 special settings, right? What is it? So both G and I cannot be there. So even, where is it gone? Sorry. Yes, so both G and I cannot be there. So it's either it might contain G or it contains I. So let's look at 2 cases. One is it contains G. So if it contains G, then it cannot contain I. I know that already. How can it contain? It cannot contain both. So in that case, the longest common subsequence, I can better forget that I can say, oh, okay, just look at then the longest common subsequence between this and this. This is one possibility. Another possibility is it doesn't contain G, it contains I. In that case, the longest common, or it might contain I. In that case, the longest common sequence between these two will come, not G. So here we break into two pieces, right? So this I and G are different, which means that the longest common sequence between LCS 6 and 4 is the max of the longest common sequence of 5 and 3, or 6 and 3, or 5 and 4. Okay. And we progress like this. So this is basically the recurrence that we are talking about. It's the same thing. This is exactly what we are doing for the last 3 classes. You have a problem, you think about how to break it up into some smaller recurrence things, right? So we can think of a pseudocode like this. Basically, the starting things are this thing, and the LCS of ij, if ai is equals to bj, then LCS of ij is nothing but LCS of I minus 1 j minus 1 plus 1. Else means if ai is not equal to bj, then LCS of ij is max of I comma j comma 1 j minus 1, or I minus 1 and j. So is this clear? Okay. So I can see some new faces in this class. Excellent. Let me think about it. So Ayanova,
Yes, sir.
yes, can you tell me what is the runtime of this pseudocode? Or what is the runtime of this algorithm?
Uh, it's actually something like exponential, like order of 2 power
Okay.
2 power n or 2 power n plus n or something like
Why?
that. Like we can see that the depth of the recursion tree, like the recursion we're doing here,
Yeah.
is like order of n plus n. So from this we can say,
Okay. But can you do better?
yeah, like if we apply the dynamic programming strategy, like storing the values of LCS I and j in an array,
Right.
then we can do better.
Okay. So how will we store? In which array?
We can have an array, like 2-dimensional array, or you can say a matrix, and the row will be the index of the first string, and the columns will be like the index of the columns will be the index of the second string, and like this we can, like if we just iterate over the array by column measure or row measure order, we can just store the values one by one, and then just like in each iteration, we can just check the values of the first of all the diagonal, like the previous diagonal term, and the above term, and the
Right.
upper term and the left term, and we can compare and we can get the value.
Very. Yeah. So good. So basic thing again, I repeat something similar to what we have done earlier. When we have a recursion like this, we have to somehow ensure that we don't end up doing the same computation multiple times. And in this particular problem, that is going to happen. We might end up doing the same computation multiple times because we are branching out, right? Like this is LCS of I j minus 1 and I minus 1 j. The next step will be, again, there will be an I minus 1 j minus 1 under this string, and similarly under this string also. So you realize therefore that we are ending up, if you just plainly use a recursion, then it is not very useful. But we can use dynamic programming, and which is nothing but just storing the necessary information. That's it. Okay. So how do you want to store this necessary information? Let's see. Yes. So you create a array. So you have this thing here on top. That is the recurrence that we have in mind. You create a new matrix indexed by the rows. How many rows are there? It is, so this is n, this is m, right? So it's n plus 1 and m plus 1. And now I want to store them. So every quantity here should be the LCS of ij will be kept. So the 3, 2 will be LCS of 2, 3, right? 2, 3, or LCS of this one is 7, 8. And our job here is to find out the LCS of what 8, 6, right? Which is the last bit. Now, of course, I don't know how to compute the last bit straight off, but I also know how to compute some of these internal ones. First of all, I can start with this first row. What will be the first row? Amay, Nikam? Hello.
Yes, sir.
Yeah. Can you tell me what all things will be put in the first row?
In the first row, all will be 0.
First row, all will be 0, right?
Yeah.
And what about the first column?
Same. All zeros.
First row, all is 0, and first row column, all is 1. So once I am done with this, then how can I fill? Which one the next should I fill? See, our job is to fill using this set. Okay, so look at it. This I minus 1, j minus 1, either we look at the diagonal entry or we look at the top and side entry. So anything for which the diagonal, top and side are taken care of, we can use it, we can fill it. So for example, I can fill this point. And what is this point? Okay, since C is not equal to V, this must be LCS of this left one or right one, maximum of that, which in this case is 0, right? That's what we'll prove. The next one, I is not equal to C, and you keep on doing it and you will get 0 of all of them. Then we come to this one. This one is again, this is I is not equal to V, therefore it will be maximum of these two, the top one and the side left one, and it will be 0. Okay, then it will be this one, I is equals to I. So this one is this plus 1.
Plus 1.
So that is 1, right? Now from one, what about this? This is again I is not equal to L, so it's maximum of the left and right and top, next left and top, and it will be 1. So you keep on doing it again and we'll get 1. Then we go for this one, T, then again all of them are last plus 1, and we do it one by one. They come to here, I again. So this is 0, but this one is I and I. See, I and I, by definition, I have to look at the previous, the topmost thing, right? And which is fine, which is 1 again. We are not making any progress whatsoever. And now for the E, also we don't make any progress. Everything is fine, except unless we come to here. Here it is E and E. So it is the previous top one plus 1. Right? So this is 2. And similarly, we fill up all of the rest of them. And at the end, we get this S and S, which is this 2 plus 1, which is 3. So from here, we can say that the LCS of between the villages and cities, these two strings, is 3. Now, few things important things to note is that for any point, we are spending constant amount of time. How many points are there? There's a n cross m points are there in the matrix. So the time taken to fill up the whole matrix is order n times n. Now, is this clear?
Sir, it's clear, but by this matrix, how we can find the
The actual
sequence?
subsequence. Actual
Yes.
subsequence. Right? Yes.
Yes.
Can you tell me how we can find?
Where first came, where one came, where two came, where three came.
Yes.
That
So
is
tell
what
me. So tell me how we can find.
I, one first came is I, two first
First,
came is E.
say here when you are first time you put 1.
Yes, yes, that is what.
Okay. I want to say that this came because of what? Why did this 1 came?
Because I
Because
and
of
I are
massing.
equal.
Because I and I are equal. So that means I have used this I at the end. Right? So I would, instead of string 1, I would put the string. So let's say we store in each string the longest common subsequence and the weight both. So here I will of course store 1, but I will also store I. The I is the longest common sequence here. What about this? This is the max of these two. The previous left one will contain I, saying that I is the longest common subsequence. And since I'm doing the max of these two, so this also has to be I only. So I'll keep I for all of them till I come here. Here, what is it? Oh, this E and E. This two came from this plus this. Note that in this time, in this square, what else is stored? I am storing not only just 1, the size of the subsequent, but also the subsequent, which is what? I, right? So I know that this came from this corner because I was there and I had to add an E at the back because that's how I have added. That's why. So this one therefore will contain I, E. Similarly, this one will also contain IE because this is coming from. So look at from where it is coming. Okay, just like this thing has been written, this recursion has been written just for this size. You can write it for the string also. For example, if AI is equals to BJ, then LCS, the longest common subsequence, forget the length of IJ, is longest common subsequence of I minus 1, J minus 1, appended with the AI at the end. And in this case, it is the longest common subsequence, the subsequence that is there maximum with the longest length between this and this. So that is one way of writing, ensuring that I always maintain the longest common subsequence. Is this clear, Venkatesh?
It's clear, sir.
Okay, there is another way of doing it. Okay, so this way of storing it has a problem. What is the problem? Can somebody say what is the problem? What I just now told?
The augmentation increases space complexity of the procedure.
It increases the space complexity of the procedure, right? Because every time I'm basically storing this huge string, right? The other option is that instead of using this whole thing, just store the place from which you got it. For example, here, since I got this one came from this 0, I will store a pointer to this 0. That's it. So every point, every entry in the matrix will contain the length of the longest common subsequence and point to the previous square from where it had got it. So from this one will point here, this one will point here, this will point here, and so on. Similarly, this will point here. This will point here, this will point here, this will point. So at the end of the day, I will have a 3 over here, and I have a pointer to the place from where it comes. And notice everything has a pointer. So this will point here, then this will point here, then this will point here, 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 right? So everything I can change the pointer now. Once I'm done with the pointers, once I know what the value is, I look at the nm value and look at I just follow the pointer. I'm taking the pointer will take me from here to here basically. Now I know that every time the pointer goes in a diagonal form, I have to, that should add to my subsequence. So once I finish this whole matrix, I look at this one and just chase the pointer and look at all the places that for which I have gone from the diagonal entry, and those places are where I will, from where I retrieve back the subsequence. Now this way it is slightly better. Why? Because I don't have to store the subsequence in each of the blocks. I am just storing the pointer. And how big is the pointer? The pointer takes only log n bits, so log m bits, right? To point it, log n plus log m bits, to point to the previous one. So of course the space complexity will go up a little bit, but not by much. It will go up by a factor of just log m plus log m, not by a polynomial size factor. Is this clear? Hello.
Sir, can you repeat the pointer idea, like how the storage is going to be logged in?
Okay, how the storage is logged in. So if I want to store a pointer which points to either 1 or 2 or 3 or 4 up to n, how much bits do I need?
Okay, yeah, so I got it. Yeah, we use that many bits, like,
yes, we use log n bits to say what is the, so I have to store the number, right? I have to store a number between 1 to n.
yes, sir.
That number will take log n bits.
Hello.
Yeah.
Yes. So in many of the cases here, there would be a tie, right? Because of the else max clause.
Yes, if there's a tie, you can choose any
So-
one of them. Doesn't matter which you are choosing.
Okay.
Okay. I mean, you will be basically producing some. Yeah, I mean, there are different ways of. I mean, there can be multiple longest common subsequence. There is no unique longest common subsequence, right?
Yes.
And how you are breaking the tie will produce your longest common subsequence.
Okay.
So if the goal is just to produce one or some longest common subsequence, this will take care of it. Okay.
Yes.
By the way, this is also the case for whatever we have done till now, namely the knapsack problem and the edit distance problem. Okay, because there also we did only the length of the or max number of edits or the amount of things that I can carry in the knapsack and so on, the value of knapsack. But one can ask the same thing. What are the elements that I should pick up in a knapsack? Or what are the edits that we are talking about? And there also we have to do by the same technique. Either we have to keep the pointer, which is usually the most effective way of doing it, or you can store the whole thing, which is somehow not the most right thing to do because it takes a lot of space and time also. So please go back, revisit those two things, and find out how you can store the pointers so that you can retrieve back this along the maximum knapsack problem.
Sir, why would the storing the string or the objects take more time as well?
Because you have to end up writing it also, right?
Okay, okay, yeah.
Okay, somehow Dhananjay claims that he is not hearing anything. Dhananjay, I think it's a problem in your end. Oh, okay, if he cannot hear this also. Okay, so by the way, so this was basically the, I mean, something that we did for the NAP, for the dynamic programming problem. I'm repeating you again. Sayantan has posted a set of other problems of dynamic programming. The basic concept of dynamic programming is very simple. It is a recursive algorithm. You want to break that whole problem into smaller problems. That's the first part of it. That's what we call as the recursive problem. Okay, this is something we have done. We will see a little bit more of it also in the next couple of classes. That is one thing. Other thing is that yes, since in the recursive thing, sometimes you end up using this or doing the same computation multiple times. So it is very important for to store them to save the amount of time complexity. It depends on the problem to problem. Now this thing, we have done this this dynamic programming only on matrix, only by storing things in a matrix form. In the example, I think you will find things where you store it not only in a matrix form, but you store it in an array and so on. You also sometimes apply dynamic programming for trees and various other graph problems also. Many of them are beyond the scope of this class, so I don't want to go into details of that. But the basic concept, I hope that you guys are following it. Break it up into small parts, then try to store the computation to solve it. So that's the concept of dynamic programming. Okay, so it's a recursion and dynamic programming, and dynamic programming is storing this. That really is one of the most powerful tools of solving problems in general. Okay, yeah. So in the rest of the class, what I will do is that I will how much time do I have? I have 1 hour, sorry, half an hour, right? Yeah. So let me ask you another question. Okay, this is not necessarily dynamic programming, but you can think about it. Okay. Okay, so there's an how. Yeah. Yes. So here there are a couple of problems that are there. If you guys can try to think about it on your own, that how can you find the longest common subsequence between 3 strings, or in general between k strings? How can you go about it? But what I am going to talk about now is what is called the longest increasing subsequence. So this is another very beautiful thing, and I want you guys to think about it today, right now. Okay, and we will solve it. So I have a string of integers, okay, numbers. These are not letters, they are numbers. Okay, and they are not sorted, they are somehow something is there, and my job is to find the longest subsequence that is increasing. Again, what is the longest subsequence? A subsequence is a subset of the string in the same order, right? And they better be increasing. So for example, say here this is a sequence of numbers. Now I can take say 1, 4, 6, 10, or 1, 4, 6, 8, 10. That can be a increasing subsequence. Is it the largest? That I don't know. We have to think about it. Okay, so it seems that 1, 4, 6, 8, 10 would have given me 1, 4, 6, 8, 10 would have given me 5 things. So here the longest increasing subsequence is 1, 1, 2, 3, 5, 6. So is this problem clear? What is the longest increasing subsequence?
The
Debru?
values are increasing, right? The
values
values should be
increasing or not decreasing, say.
Yes, yes.
Value should be non-decreasing. Debru Chatterjee, are you there?
Yes, sir.
Did you understand longest increasing subsequence?
Yes, sir. Yes.
Okay. Pradeep Das?
Yes, sir.
Yeah.
It may not be unique.
It may not be unique.
There is 1, 4, 4, 5.
Yes, it may not be unique. Just like the case of the longest common subsequence, this one might not be unique. Okay. So our job is to find the one or one with the longest increasing subsequence. And maybe a small easier problem is to try out the length of the longest increasing subsequence. Now, how will you go about it? Let me see if I have this one. Yeah. So how do you go about it? How do you prove it? How do you find it? There is a couple of hints. One is we've already done this problem.
We can just sort this, right? Sort this and take it as this.
Hold on. Yes, very good. Akshay, very good. Yeah, let's say other your friends think about it. Yes. Maybe why don't you guys, once you have some ideas, why don't you send a message to me? How do you solve it?
Sir, I have to find the length together with the subsequence, right?
Yeah, I mean, let's start with finding the length.
Hello.
Yeah, let's start with finding the length first. Hello.
Yes, sir, but I need the subsequence also.
Yes, we need the subsequence
Previous
also.
subsequence.
Yeah.
So I will check the last element and check that if the last element is greater than the previous subsequence, previous longest subsequence. I mean, I will check that AI.
Okay, Thomas, Thomas, you are going the right direction. Why don't you try to just maybe write down on the formal recursion?
Okay.
Okay, and maybe send a message. That will be useful. Dhananjay? Dhananjay, are you there? Can you hear me? Hello? Dhananjay, you have sent something which seems to be a very abstract way of saying anything. Can you be a bit more formal?
Sir, are you saying me?
No, I'm not. I'm saying Dhananjay.
Hello.
Yes. Hello. Can you hear me?
Hello, sir.
Hello.
sir.
Can you hear me? Yeah. Hello. Yeah, Dhananjay, can you hear
Hello,
me?
sir. Yeah, hello, sir. Can you hear me?
Yes, I can hear you now.
Yeah.
Yeah, so you have told something very vague. I mean, like partition it in subsequence and something. Can you?
First of all, sir, we partition the sequence of the.
Yeah, I mean, can you give a more formal stuff? What does it mean by partition? What does it mean by? I have no idea.
Partition is, sir, actually we take the partition as possible as the increasing order of their increasing order. And then we combine this increasing order. Those are those partition are the increasing order, and then we combine this partition.
Can you be a bit more formal? What do you mean by partition? What do you mean combine? Can you write? We have been talking about formal ways of going about it, right? Can you give a recurrence if you are actually using a partition? So Thomas Kanti correct?
Yes, sir.
Yeah. So do you think that this recurrence is correct? Yes. You're saying that the last
Yes,
element
sir.
is bigger
I
than
think, but I may be wrong.
Yes, you're saying the last element is bigger than the previous one, then you do n plus one, and else you're going to completely forget that. Right?
Sir, if it is not bigger than equal to the last element of the previous subsequence, then we cannot include it in the longest
No, but
increasing
we can
subsequence.
include
Right?
it. What do you mean we cannot include it? For example, if this is subsequences of the form 1, 2, 6, 8, 7, and it is maybe 2, 6, 7, 9. Oh, sorry, what I'm talking about it. Yeah, so this thing. Okay, so you mean that in that case you might want to add this thing? Okay, that also
Yeah.
no, it's that also is not true. For example, this can be 9 and this can be 8. Okay.
Okay.
So for example, this one is fine. You want to add it, right?
Yes.
But then you have this one. Here you have 7.
Sir, is it the last element? 1, 2, 6, 7. Yes, it's the last element.
If it is this last element, you say, oh, this is not bigger, then you will not take this one. But that's not good, right? Because
Sir, LIS is giving me the longest subsequence of the sequence of size I minus 1. then I can add 8 to it if 8 is greater than the last element of that subsequence.
Yes, but what is the last? What is the sequence here? What is the LIS of this thing?
The
1, 2, 3,
previous
4.
one 1 to 6, 7.
So
Or
maybe
1
let's
to
say
6,
this one.
9.
What is the so last element is bigger than this. 8 is bigger than 7, right? So 1,
Yes.
2,
No,
3,
last
4,
element
5,
means the
6, 7.
LIS, longest increasing subsequence. I am
Yes,
talking about that subsequence is last element.
So you're talking about the last element of the largest increasing subsequence. Okay,
Yeah,
so you're
yes.
basically maintaining the subsequence and doing it. Okay,
Yes.
so how will you maintain that? Okay, so you have to basically store that whole thing, right?
So I can store the last element only, not the whole thing. Only the last element.
Okay, you can try to store the last element. That's good. You can do that. Okay. What about the rest of you guys? Are you guys doing it? Devarshi? Devarshi?
Hello, sir. There was some problem with my mic, so I cannot formalize it exactly. I am thinking about something like storing subsequences of possible lengths starting from 1, 2, 3, and I keep updating the last element when I find the element that is smaller than the current last element and greater than the element before the last one. So a valid element that is smaller than the last element. And
Yeah.
we maintain the arrays of subsequent lengths and we keep updating. So in this way, when we encounter, suppose say, first I say instead of 162, here there is 162. Then we first have 1, then 1, 6, and at the next iteration we see that 2 can be placed in place of 1 and give us a subsequence ending with a smaller element. So
Right.
we update that to 1, 2, and we keep going on accordingly, but I cannot exactly formulate its complexity, you know. So I think
Okay, see,
more
in
on
this
that.
kind of situation, there are two things that is important. Okay, and this is true for A. So yes, you have seen, all of you are kind of defining LIS of I as the longest common as the longest increasing subsequence. Increasing subsequence of A1 to AI, right? This is what you are defining. And then you are getting struggling mostly because when you want to kind of go ahead, it's not very clear that you want to look at the previous item. You want to look at the actual longest increasing subsequence. So maybe this is not the way to go about it. Let me define it slightly differently. Okay, so maybe I'll cross this one out. And what happens if I define this object? This is the longest increasing subsequence of A1 to AI containing AI. So I'm forcing that longest common subsequence to contain AI. Okay, it has to contain AI. In that case, can I define what is LIS of say n? What is this? This is of course not the final answer. LIS of n is not the final thing, right? But this is the longest common subsequence that contains the AN. Okay, now question is when can it contain AN? So what is the previous one? If it contains AN, that means the previous one must be less than AN, right? In that case, can you write the recurrence for this LISN?
Sir, if the last element is the minimum
Sir,
of the array,
Then it will be, what will it be? Tell me what will happen.
then only the last element will be there, right?
Yes.
In the
Yeah, that will be the last element. That's it. I'm not saying that this is the final answer. I'm just saying that this is a storing thing, right? This is the minimum. If I can make this thing, if I can store this information, see, if I can compute this information, it is the longest increasing subsequence of A1 to AI containing AI. In that case, shouldn't I output finally the max of our I equals to 1 to n LIS
Yes,
of
sir.
I?
Yes,
that
sir.
would be done, right?
Right, sir.
So all that matters, and this is just a max of n items. So it's order n steps. So the question is that what can you do with this thing? How do you solve this? Now that's all that matters, right? Think.
Sir,
What if
sir, to
we
contain an means here alias of n means an is there in that, right?
Yes, yes, an is certainly there in that lingua.
So it should be longest increase in sequence. Then we have to look for the elements which are less than an.
Right.
Then we have to check which one is giving maximum longest LIS.
Exactly. Very good. So yeah. So somebody else was saying something.
Yes, I was saying what Venkatesh told us.
Okay. So you have the same thing, right? Right. So this is max over all the I such that AI is less than or equal to AN LIS of I.
And I less than n as well, right?
And I less than n, of course. Yeah. Look at all the i's for which AI is less than or equal to n and do this. So this will be a way of filling up this matrix. Now let's see what is the time complexity of this whole thing. So is this clear, this recurrence? Devdatta Kanungo, are you there?
Yes, sir.
Yeah, is it clear? God. Hello, Devdatta Kanungo. Okay, maybe he is not there. Shubinoy?
Yes, sir.
Is this clear?
Yes, sir.
Sure.
Yes, sir.
So what is the time complexity of this?
Time complexity log n time.
Log n times. Why log n?
Sir.
You know, I mean, at least he told something, at least give some idea, argument for that. Maybe it is wrong, but at least don't keep quiet. Shima, are you there?
Yes, sir.
Yes, can you tell something? Why log in? How are you thinking? Shubinoy, can you please say something? How are you thinking?
Sir, network something.
I don't think there's no network issue. Are you saying something?
Yes, sir.
Yes, what are you
Actually,
saying?
sir, sir, mm, mm,
Are you not saying, or is it again a network problem? Okay. Devdatta Kanungo, are you there?
Yes, sir.
Can you say how to the time complexity of this? Come on, say something. If this did you follow it or not? Am I audible actually?
Yes, sir, you are audible.
Excellent. So why are people becoming silent as soon as I'm asking some questions? Is this a way of kind of at least tell how you're thinking? If you're not understanding, tell me. I mean, like, come on. I'm trying to help you guys. Excellent. Sutirtha Ghosh.
Hello.
Hello.
Sir.
Yeah.
Yes, sir.
Can you tell me what is the time complexity of this algorithm?
Sir, is it n log n?
Why is it n log n?
Sir, because for each step we have to search the previous step where is the maximum is we can found.
So for this step you're saying, right?
Yes, sir.
Okay, but for that, why is it n log n?
Sir, for each for n we have to search the previous n-1 step.
Right, right.
Then for n-1 we have to search the previous also.
Yes.
And sir, so it is n log n.
I don't see how it is n log n. Yes, it is true that to solve this one, you have to search n objects. So there can be n things. For each of them, you have to check whether I is less than n or this whether ai is less than n. And if so, we want to put that value. And after that, we are taking the max of this whole thing. So
Yes,
why
sir.
is it n log n? Why is the log n coming?
Because we have to find the maximum.
Okay. How much time does
among
it
the
take to
previous.
find a maximum among a set of n elements?
Log n, sir.
To find a maximum among set of n elements, take log n steps. Sudhita, how much did you get in your midsem?
Midsem.
Yeah.
48. Sir.
You got 48 in your midsem.
Yes.
And you think that the finding the maximum among set of n elements take log n steps? If I give you n elements, how much time does it take to find the maximum among those things? Can you write a pseudocode for that to find the maximum?
Sir, we can do it in order n, but sir.
Yes, you can do it in order n. But why does log n come in? So you are a CS or CRS student?
CRS, sir. CRS.
You're a CRS student. Okay, it takes order n steps, and that's the best that you can do.
Yes.
I mean, no, yes, sir. It is order n. Okay.
Yes, sir. The order ends.
Yes. I don't know how much you have understood. I have doubt about that now, very, very much.
No, sir. Order n. I understand.
I don't think so. Why not log in?
Sir, for searching, it should be log in. For finding maximum, it should order in.
Are you memorizing it or what? I mean, come on. I mean, did you guys, did you ever go to the tutorial sessions?
Yes, sir.
You've gone to the tutorial sessions. I mean, I don't know. This is like a very basic thing.
No, sir. Sir, actually, I was wrong.
Maximum, you can do
No,
the
sir.
log.
I was wrong, sir. It is order in.
I mean, of course you were wrong, but question is that how are you so wrong? So for every step you take order n steps to compute.
Yes.
So how much is the total time complexity?
Order n square, I think.
Okay, why?
For n we have to search n, and then for n minus 1 we have to search the previous n minus 2 elements.
Okay.
Actually, we have to find the maximum for the n minus 2 elements, and that's and so the total time is 1 plus 2 and so on n minus it should order n square.
Okay, and then you have to count the output. I have to output the maximum of this also. So
yes, sir.
Then how much time will it take for outputting the output maximum?
Order n square.
So to write down the whole array for computing the LIS of all of the points, it takes order n square. And
Yes.
for outputting the maximum of LIS, how much this operation take? How much does this operation take? Okay, it's take order n, it's written right beside it. So for computing a single, so for computing LIS of I takes order I steps. So computing LIS for I for all I from 1 to n takes summation of order I equals to 1 to n, which is order n square. Computing max of LIS I takes order n steps. So the total takes order n square plus order n, which is order n square. Okay, so this is what computing the LIS takes. Now, while this is correct, you could have done it in a slightly more easier way. Okay, why? So this is a concept what is called reduction. And one more concept in algorithms that we will be doing a lot in the next few weeks, couple of weeks. Okay. So of course you can do this one, but what happens if I sort this string A1 to AN? Then the new sorted string is B1 to Bn, say it is just a sorting of A1 to AN. And now if I have these two strings A1 to AN and B1 to Bn, and I find the longest common subsequence between these two strings, then what do I get?
The longest increasing sequence.
I get the longest increasing sequence. So instead of reinventing the wheel, I could have just sort it and find the longest common subsequence between these two elements. How much time does it take to find the longest common subsequence between these two elements? This is string, order n square. How much time does it take to sort it? Order n log n. So all total is order n square. So this is what is called, okay, so you can go and prove that this is actually the increasing sequence. I don't want to go into the proof formally. Yeah. So this is another very important thing. Like, see, in algorithms is all about a few way of thinking about how to go about it algorithmically, which is sometimes not very intuitive. For example, thinking about it recursively and all those things. And some of it are very obvious ways to kind of being lazy. So, for example, dynamic programming is one of them. In some sense, it's a lazy algorithm in which you write down what you have computed and use it later. Similarly, here, what I'm talking about is this important concepts of the word, this reduction. Something that we will do it again and again in the next, I mean, for quite some time now. Okay, where the job is, and this is something that is very important when you go about in your industry, go about doing a job in your whatever place you go. You don't want to reinvent the wheel. You don't want to design a whole algorithm all by yourself. You want to reduce your problem to some other problem for which there is a ready-made solution. This is this concept. Okay, nothing but I have an access to some other problem, in this case longest common subsequence problem. Can I reduce my problem to a instance of longest common subsequence problem and use it? This is what is done in the industry all over the place. All over the place. Anywhere you want to say. Okay. So your ingenuity is in identifying the problem to which I can reduce it. If I can reduce it to some other problem that I know how to solve, then I have made progress. Okay. So, I mean, this is something that we will be going about it. If you guys have heard about concepts like NP complete, NP hard, all of them, they are based on this simple concept of reduction. It's something that is very, very essential, and we will be focusing on that in the coming weeks. So I think I will stop today. And yeah, I think I will stop today right now. I will, in the next class, let me go into, so we have seen a little bit of dynamic programming. We have seen some amount of recursion. We'll see one more concept of recursion, recursive algorithms. The recursive algorithms are also known as divide and conquer algorithms. So many times sometimes you don't have to store them, but basic concept is same. You want to break it up into smaller problems and solve it there. So in the next class, we will be looking at some other divide and conquer algorithms, and we will continue from there. So the way in which we will progress from now on is that we will have a couple of weeks of divide and conquer algorithm. Then we will go back to greedy algorithm for a couple of classes, in which we will do some machine learning algorithms, some beautiful machine learning algorithms. And finally, we will go back to another this concept of recurrence, reduction. These reductions that we have to go back to. Okay, so these are the basically this few concepts that we will be learning throughout our this course. We have already seen a little bit of greedy algorithm. We will see a little bit more of it. We have a divide and conquer algorithm, or if you want, you can call it as recursive algorithm. We'll also see a bit more of it. There is this concept of dynamic programming. We have seen, and I will not go into dynamic programming much, but I would really ask you guys to please go and solve the problems. And other than these concepts, we will go into reduction. And this is another very important concept that we have not touched that much. And this is something we will be kind of the final chapter of, you can think of this class of algorithm C. Of course, there are other algorithmic concepts that we will be not be touching in this course. See, every problem will have every direction, there will be some special problems that has to be solved or that can be solved. Many of them we will not be doing it, but also there are some other completely different ways of doing things like amortized algorithms and so on, but that also we will not be doing it. But we have seen these three things. We will do a few more of these three things and a little bit of this. So I want you guys at the end of this course to be at least comfortable with these four concepts and be able to design algorithms, or given a problem, kind of understand how to go about attacking. Should I try greedy? Should I try divide and conquer? Should I try dynamic? Or should I use a reduction to some other problem? This is the goal of algorithms. Right now, our base is more or less set. If you guys are struggling, which many of you are, all I can say is that please identify yourselves and come to the TS, make yourself ask questions, something of that form, pull up your socks. I think if you have struggling so badly that you don't even know how much time does it take to find the maximum of n numbers properly, then please identify yourself and we will help you, but you have to identify yourself. You have to come and seek our help at least. Okay, I think I'll stop here now. Okay, so before I close, any questions, doubts, comments? Okay, if not, see you on Wednesday.